Hello everyone, this is our summary of algebra and there are two algebra summaries, algebra 1 and algebra 2, so try and get through them quickly, but there is a lot in algebra. First of all, the difference two squares. Okay, you know this from junior cert, but one thing to watch out for is 4x squared minus 81y squared is not 4x minus 81y times 4x plus 81y. You have to recognize 4x squared as 2x all squared minus 9y all squared, and then it's the first plus the second times the first minus the second. So just watch out for that. And I say that in particular because when you go over to cubes, you have a similar thing to watch out for. Okay, so for the sum and difference of two cubes, the terms, you need to remember these formulas. One thing that might be helpful to remember is that the terms are the same. xy, xy, x squared, xy, y squared, x squared, xy, y squared. The first bracket has x and y to the power of 1. The second bracket has every way of combining x and y. X by x by y by y. The difference is where the pluses and minuses go, and one way of remembering this is if there's a plus at the beginning, there's a plus in that first bracket, minus at the beginning, minus in that first bracket, and then there's only one minus in the expansion. Maybe that's a way that would help you remember it. And here's an example, 8a cubed minus 64b cubed. Recognize the 8 as 2a, or 8a cubed is 2a all cubed, 64b cubed is 4b all cubed, and then use your expansion. Okay, you do need to know those, they're not in the log tables. Okay, the roots, very important concept. The roots of a function are the solutions to the function equal to 0. Okay, they're also the x-intercepts, because when you set the function equal to 0, you're setting y equals f of x. If you set y equal to 0, that is the equation of the x-axis. So the roots are also the x-intercepts. A factor of f of x divides into f of x with 0 remainder. So here I want to link roots to factors. So when you divide a factor in, you have 0 remainder. That's something to remember. And if you have a root, you have a corresponding factor. If you have a factor, you have a corresponding root. So the roots and factors, how they relate to each other. If you have a factor, if a function has a factor of x minus 3, it has a root of 3, and that means that the f of 3 is equal to 0. These are all things you need to know. And you can see the corresponding roots and factors. If you have a root of minus a half, that means you have a factor of x plus a half. Or you could view that as a factor of 2x plus 1. Both of those give rise to a root of minus a half. And here I've just reiterated what I've said below here. If 5 is a root, then f of 5 is 0. X minus 5 divides into f of x with 0 remainder, i.e. x minus 5 is a factor. Now, the number of roots of a quadratic is determined by the discriminant here. They like asking about the discriminant, they like asking the number of roots. So for a function, ax squared plus bx plus c, there's your quadratic function. How you remember what determines the number of roots is what is under the square root in the minus b formula, because that's the thing that will determine the number of real roots. If that quantity b squared minus 4ac is less than 0, you have no real roots, you have complex roots. That's for another time. If that is equal to 0, b squared minus 4ac, then there is only one real root. There's one x-intercept. They're called two identical roots because something like this could be like x minus 1 to be squared. So x equals 1 is your root, and it's called two real roots, two identical roots, because I don't know, x equal to 1 is identical to x equal to 1. And then you've two real distinct roots if b squared minus 4ac is greater than 0, because in that minus b formula you'll have the root you get from minus b plus the square root over 2a, and you get a second root from minus b minus the square root over 2a. Okay, so b squared minus 4ac determines the number of roots. Keep those pictures in mind, and also recall the thing under the square root will determine the number of roots. Okay. Solving cubics, so solving cubic equations here, top left. Unless you're given a root or maybe a factor to begin with, you guess and check. Okay, so guess and check. So try x equals 1, minus 1, 2, minus 2, 3, minus 3. By the time you get to minus 3, you should have come up with a root, otherwise life is too difficult. So if you find a root, like say for example above here, you find that minus 1 is a root, turn the root into a factor, x plus 1 is a factor, and then divide the factor into the cubic. And what you have then when you do that long division is that the cubic is equal to x plus 1 times the quadratic on top. That's what the division gives you. And then you can solve the quadratic, which we can always solve to find the remaining roots. Okay, so just remember those steps. If you're not given a root, guess until you find one. It's the one instance in Leaving Cert Maths you get to guess. Turn the root into a factor, divide the factor in, and solve the resulting quadratic. Okay, if you have a square root in an equation, square both sides until the square roots disappear. Note, check your answers. If you solve this equation here, square root of x plus 1 plus the square root of x equal to 3, you may come up with two solutions. You often do. And oftentimes one doesn't work because you can't have the square root of a negative number. So you can't have minus 2 plus 1 under the square root or the square root of minus 2. So when you square both sides, sometimes you end up with a solution that you just can't have under the square root because it would result in a minus under the square root. So you'd need to eliminate that. Okay, so watch out, check your answer. Simultaneous equations in three unknowns. Take two equations, eliminate one of the variables, take two different equations or one in common and eliminate the same variable. You will end up with two equations in two unknowns, which are the simultaneous equations you're familiar with. Okay, so just know those and then sub back in to solve for the remaining variables. Know those steps. Let's see, absolute value, square both sides, and if you have an inequality, square both sides, and in this instance here we end up with a quadratic inequality, so we need to know how to solve quadratic inequalities. So how I would solve them is find the roots. So put the quadratic equal to 0 and find the roots, sketch, and then figure, okay, do I need where the function is less than 0 or greater than 0? In this instance, less than 0, which is the green part of this graph here. And then you need to figure out the x values that give rise to those green y values that are less than 0, and that's x between minus 2 and 1. Okay, now with quadratic inequalities, they also arise when you go to solve rational inequalities, so inequalities of this form. One thing in general to keep an eye on with inequalities, I have it over here, is to be careful. If you're multiplying across or dividing across by a negative number, you must change the direction of the inequality. And that becomes relevant up here for your rational inequalities because you'd like to multiply across by x minus 3, but you don't know whether that's positive or negative. So you multiply both sides by the square of the denominator. Okay, that will give rise to a quadratic inequality, and when you have the quadratic, find the roots, sketch, and figure out what values you want. In this instance, you want where the quadratic is greater than 0, which is along the green arms there, okay, green bits here, which correspond to x values that are greater than or equal to 3 or less than or equal to minus 4. And just be careful in this kind of irrational inequality situation, there'll always be a value of x that x can't be because it would result in 0 in the denominator. So 3, that value will always appear as an endpoint of your interval in your solution. So in that instance there, you need to get rid of x equal to 3, and your solution is x less than or equal to minus 4 or x strictly greater than 3. So just watch out for that. That value that x cannot equal should end up as an endpoint of your interval, and you need to get rid of it. Okay. And then simultaneous equations, if you've quadratic and linear, so two equations and two unknowns, you can always use this method. Use the easier equation to write one variable in terms of the other and then sub it into the second equation. All right. And then for the abstract inequalities, I know we've talked a little bit about these already. If you want to show something like this is true, manipulate it algebraically until you end up with a true statement, and a true statement is something of the form something squared greater than or equal to 0. You know that's always true. So manipulate, multiply across, factor, do whatever you do, and then you end up with a minus b to be squared greater than or equal to 0. That's always true because anything squared is greater than or equal to 0. So hence the original inequality is true.